So first we need to look at particle theory. So this is a central concept in chemistry, and it's really important to understand what particle theory is. So it states that all matter, everything that we see around us, is composed of tiny particles that are constantly moving, okay? Now the motion is determined by the particle's energy. So if a particle has a lot of energy, it will move, similar to a kid. If a kid has lots of energy, they'll be running around, and its relationship to other particles. So for instance, a particle moving in this direction, if it collides with another particle, then obviously they're interacting and its direction will change. Just like a billiard ball here that we can see here. If two billiard balls hit each other, then their direction will change, and that changes their motion, okay? And that's what it means. Now this particle theory can be used to describe any state of matter that we see. So now that we've got particle theory, or the basics of particle theory, we can subdivide matter into three categories. And the first is elements. So as you can see here, an element only seems to have one type of particle in it. See, there's just the brown particles here, or the green particles here. They're just one unit, one type of particle. You can have compounds. So as you can see here, you've got a blue and a yellow particle combined together. It sort of repeats itself. Or here you've got two white particles and a pink particle combining together. So that's a compound. And we'll talk about all these in more detail later. And mixtures, where you can have compounds mixed with other compounds, or so you can see there's the compound here and another compound here, and they're all just mixed together. And you've got two compounds here mixed together, and that's what a mixture is, okay? So we'll talk about each one now. An element. What is an element? So an element is any substance composed of only one type of atom, okay? So just one type of atom. So any substance on the periodic table is called an element. Okay, so anything you see on the periodic table, we call that an element. A block of an element has only one type of atom in it. So it's easiest to visualize what an element is with a pure metal. So a bar of gold, like we see here. So a bar of gold is just a bar containing only gold atoms. That's all it does. And each element has a unique symbol and unique properties. That's what makes them different. Now a molecule, now these are particles that are composed of two or more atoms chemically bonded together. So it can be two or more atoms. They could be the same atom, they could be different atoms combined together chemically. So here we've got sort of one circle here bonded with another circle here, and that gives us our molecule. Molecules can still form elements. So O2 is considered elemental oxygen. So for instance, because you can see that the oxygen only contains oxygen. The oxygen gas only contains oxygen, but they just happen to be bonded together. So that means it's still an element because it's still only composed of oxygen atoms, but it's just a type of oxygen gas that we see. So oxygen gas only has O atoms, they're just bonded together. And a compound. A compound is any substance formed from two or more elements that are chemically bonded together. So the difference between a compound and a molecule is that a molecule can include compounds as well as elements, but a compound has to have two chemically different elements bonded together. Two different elements, two or more elements, as in different elements, bonded together. Now compounds have a fixed composition. So for instance, if I had carbon dioxide, or water in this case, let's go with water. So water is a compound, H2O. In water, there will only ever be two hydrogen atoms for every one oxygen atom. So you're not going to find a water molecule that has two hydrogen atoms and two oxygen atoms, because that's a completely different chemical. So you can see that compounds have to have the same composition to be called the same compound. So H2O2 would be a completely different compound to H2O. So under the right conditions, compounds can be broken down back into elements. Mixtures. So mixtures are substances that are formed from two or more different substances. So mixtures are a really broad category. It's just when you mix together two or more different substances. They could be elements, they could be compounds, doesn't really matter, just two or more of them. Now most substances that we see are mixtures, just because that just happens to be what we see in the world. Now the difference is that they're very easy to separate. So I could separate salt and water very easily, just boil the water away. I could separate sand and water, just filter it. Now the reason they're easy to separate is because they're not chemically bonded to one another. Okay, they're not linked together by chemical bonds. Now mixtures have no fixed composition. Like in compounds, we saw that you could only ever have one oxygen for two hydrogens. But with mixtures, you can have an infinite array of compositions. Let's take salt and water. Salt water is a mixture of salt and water. However, you can add different amounts of salt, but you still call it salt water. If I added 10 grams of salt to 100 milliliters of water, that would still be called salt water. And if I was to add 100 grams of salt to 100 milliliters of water, that would still be called salt water. So you can see that I can change the composition, but we still call it the same thing. So that makes it different to a compound. So that concludes today's lesson on classification of matter. We've looked at what are the main categories of matter: elements, molecules, compounds, and mixtures. And then we've looked at the properties of each of them. Okay, so we'll move on to the question segment and we'll see if we can answer some questions.